Yes, this is very much the end of the conference, and it's obviously hard to keep energy levels up. This particular presentation is going to be a little bit different to the others in the sense that I'm not really presenting research data itself. I'm sorry, not research itself, but the actual collective worth of an effort that all these projects have done in terms of making that information available. So first I thought I would give a bit of an introduction to what we actually do with the eAtlas. And the eAtlas is kind of like a portal where there's data sets and articles, and each of the projects in the program have a particular site here where we collate all of those data products that they produce. So here we're looking at one of the Gully projects. And you can see there's a data set that they have produced, which is that gully mapping. The data is available, it's documentation about what it shows, the actual data, you can download it if you like. And then for any of the spatial data sets, you can look at an interactive map to actually sort of drill down and have a look at that data in a little bit more detail. And the idea of these visualizations is they allow you to get a sense of the data, work out if it's relevant for your research, and also investigate it a little bit in a little bit more detail. But the other thing that we do is bring together all the data from lots of different projects, and so they start to be able to tell sort of stories about interconnected stuff. So here we're actually going to bring up the seagrass data that Alex showed earlier. And then by looking at this data set, we might look at, well, let's have a look at the distribution of dugong from aerial surveys. And here we're actually bringing up data from the MetSurf, which is quite old now, but it shows that like that connected legacy of data telling those stories. And if we get in a little bit closer, in this case, well, we'll rearrange the layers so that the seagrass is on top. We'll make it a little bit transparent so we can see through it. And actually in this case I'm interested in only more the shallow areas where the depth is not less than 20 metres. So here we can actually see sort of the relationship between where you've got lots of seagrass and high incidence of dugongs. And in that relationship, you know, you can kind of see a pretty strong relationship between where you've got large seagrass meadows, you tend to have lots of dugongs, which is not very surprising. But it does show that connected nature of multiple data sets telling a bigger story. As well as that, we also worked on a few projects where we tried to compile sort of the stories that are driven from data sets. So in this case, this was presented earlier on the cumulative impacts. And they developed a whole bunch of modelling and they compiled a whole bunch of data, and so we presented that as a bunch of interactive elements. So this is showing the history of coral cover over time and the impacts that affected that. So if we look at one particular reef, so Davies Reef, we can see that if we look at the massive corals, those cyclone events didn't actually do a lot to the massive corals, but if you look at the tabulate corals, you can see that they actually had quite a different, big effect. So these interactive elements allow you to tell stories where you have lots of data and you're trying to tease out the different stories that can be told with that data. So the eAtlas itself is really a big community of data. It's only as valuable as the data that drives it and the engagement of all those research projects in terms of making their information available. And I guess I'd like to sort of go back a little bit in terms of telling a little bit of a history. We sort of started the eAtlas, well, it's quite a while ago now. The actual origins started sort of, I don't know, 2008-ish. And then we kind of really started getting going under the MetSurf program. And at that stage, the approach to data management really wasn't that well established. And I remember being in the room when we actually presented the idea that people would have to do data management and they'd have to do some effort to actually make their information available. And just the shock on their faces, and the realization that they hadn't considered it at all and they hadn't planned for it, which meant that that was time that they were taking away from their research to actually get this job done. So under that program, they were only required to actually make metadata available, not the actual data sets themselves. And so not surprisingly, we actually didn't get a lot of data out of that program. Under NERP, it was much better. There was much more expectation. People were contracted to provide data, and they were expected to make it publicly available. But we kind of actually failed to, I guess, really appreciate the full complexities of gathering lots of data. And really, we didn't have a good record of, okay, we're expecting these 4 data sets from this project. Let's make sure they deliver them. And so when we got to the end of the program, it's kind of like, okay, are you done? Do you have any data sets for us? And they're like, no. It's like, okay. So there wasn't a lot of really fine-grained tracking of data delivery through that process. And under NESP, it's been much more rigorous, where we've had a lot of discussions along the way to identify those data sets which are going to be delivered, and then trying to help resolve those issues. And so we've got a much higher percentage. Now, I haven't put 100% there because data is still coming in, right? And of course, there's always challenges around certain data sets, but it's really become much more of a cultural norm, and the actual data management has become sort of parts of milestones of projects, and it's very routine. So the actual process that we kind of ran was that during the life of the projects, we would try to organise a number of discussions with each of the projects to outline the expectations of the hub, outline and discuss the types of products that they would produce, identify any issues that there might be, particularly if there's sensitive data or how we're going to manage that. And in the end, we then got them to develop data management plans to identify what are those products that they're going to deliver. And then once the data was delivered, a key part was that we did fairly extensive reviews of the data sets, with the goal of trying to make sure that key questions that you would have if you were reusing data are answered in the documentation. So our main assessment was, could someone reuse this data set by reading the data, the information about that data set, and checking that they understood the limitations and what everything meant. And once that was done, we would publish the metadata, the data products, develop visualizations for any spatial data, and make them available on project pages. So I just sort of put this up as a compilation of when all the data products were published, and it does show the distribution of publication of data comes at the end of projects, which is not surprising, but essentially with the staging of projects under the NESP, once we had the first major set of projects, which were round 2, then we started to get more a drip feed of projects. And then, of course, at the end here, where we had all the round 4 and 5 projects finishing up, there was a huge influx of data. And we're still working through some of that data now. I touched on the need for having high-quality documentation for data sets. And this is actually, surprisingly, a reasonably novel concept. Often with metadata, it's really a low priority, and a lot of the metadata standards are highly technical and extremely boring. But they tend to have a lot of technical fields, which bog people down in terms of trying to fill in all this detail in these technical fields, and people just go, oh, I've got an abstract, all right, I'll copy the abstract from my paper in there and I'll be done, right? And that means that these data sets don't actually describe the data very well and its limitations. And so we try to address that by actually breaking up that abstract field into multiple sections, basically forming almost like a mini paper about the data sets. and then trying to limit the amount of technical fields that the researchers had to fill out. Because we were going to do this review process, because we were going to work with the data, if there was anything that we could work out by looking directly at the data, then it was something that we didn't have to ask the researcher to actually do, saving them some time. And basically then all that information got compiled into those metadata records. Now it was interesting to say, well, was that a good strategy? Did it help? Well, this is sort of an analysis of how the metadata records ended up in terms of their size. Now, size is obviously just a proxy for the level of detail, compared to similar records in IMOS from the Marine Biodiversity Hub, CSIRO and JCU. So here we can actually see the records that were produced under the NESP are typically 3 to 4 times more detailed than on average. So that's a really good result, and it's a really simple simple thing to apply in the future. So I showed this sort of data story where we compiled around data. So that wasn't the only one that we did. We did some more for other projects as well, where the project generated all these dashboards and they were integrated into the platform. And the NESP 3.3.3, where there was a whole bunch of maps that were created as part of that project, and that was compiled into basically a little website. And so that's basically it. Kept it short. Thank you.